Hi Year 12s! This is a video to talk about composite functions. A composite function is a function which uses the range of outputs from one function to feed in as the domain of another function. In the function shown, we say that h of x is the composition of f with g. The domain of the function f can only include values which can be outputted by the function g of x. This may appear to be complicated, but it is no different to our earlier quadratics. If we take, for example, g of x equals 4x plus 3 and f of x equals x squared, then our function h of x will equal h of x equals 4x plus 3 all squared. This equation is no different to some of the earlier quadratics which we sketched earlier on, even though it is a composite function. It is important to note that the domain of g of x is made up of all real numbers, and so is its range. The domain of f of x is all real numbers, so will encompass the range of g of x, which is also all real numbers. So therefore, the function is fully defined. What happens if the domain of f of x does not encompass the range of g of x? Then the function will not be defined. Let's take a look at g of x equals x minus 3 and f of x equals root x. In order to help us work out whether f of g of x or g of f of x is defined, we need to work out the domains and ranges of our two functions. We know that g of x has a domain and range of all real numbers. F of x is a little harder, but if we remember our integer power functions, we know that it is only present in the first quadrant of the xy axis. Therefore, it only has a positive real number and 0 domain and range. From this we can see the function g of f of x will be defined, since the domain of g of x encompasses the range of f of x. However, we can see the function f of g of x will not be defined, since the domain of f of x does not encompass the range of g of x. We can see this intuitively, since the output of g of x can have negative numbers, and there is no real solution to the square root of a negative number. If we were to find the function g of f of x, all we do is sub it in. G of x equals root x minus 3. Now we will have a look at a special type of composite function, which is the composition of the absolute value function. Case 1 is the absolute value of a function. Y equals the absolute value of f of x. This function basically means that y will be positive for all values of f of x. If f of x gives us a negative value, then we simply convert it to a positive value for y. For example, let's look at the functions f of x equals x squared minus 4x and g of x equals the absolute value of f of x. We can see that the graph g of x, the red line, is the same as f of x for all its positive values. However, for g of x when f of x is negative, the values of g of x are positive. It is reflected in the x-axis for all the negative values of f of x. Case 2 is the absolute value of a variable in the function. Y equals the function of the absolute value of x. This is a little more complicated, but it essentially gets us to sketch a function as normal when x is positive, and as if it were positive when x is negative. Therefore, we get the mirror image of the function from the positive axis on the negative axis. For an example, let's look again at the functions f of x equals x squared minus 4x and g of x equals the absolute value of f of x. Here we sketch the function of g of x, the red line, the same as f of x along the positive axis, and then reflect that image onto the negative axis. Thanks for watching and happy studying!